our today's class is linear inequalities. Today we are going to discuss simple linear equalities as well as graphical linear inequalities. So here we are having only two learning objectives of this topic in the CI syllabus. The first one is solve simple linear inequalities, and the second one is represent linear inequalities graphically. So we will discuss simple linear inequalities as well as the graphical linear inequalities. Now, before we start this topic, we know that we will have different expression in this chapter, and we will have only greater than and less than sign in between the in place of equal to sign. Basically, the difference in between equation and expression is expression is not having equal to sign and equations is having equal to sign. So in place of that equal to sign, now we will have this greater than and less than sign, or greater than and equal to and less than and equal to sign. So what does it mean if we have this sign? So what does it mean that if we have this sign, what does it mean? If we have this sign, for example, so it's greater than or more than. So for example, if x is greater than 3, so all numbers greater than 3, but 3 will not include in this, okay, doesn't include 3. Why? Because we are having only x greater than 3. For example, if we are having sign x greater than and equal to, like we will call this sign as greater than or equal to at least. So here if we are having, for example, x is greater than and equal to 3, so here we will take all numbers greater than or equal to 3 includes 3 also. So here when greater than or equal to sign we have, okay, then in that case we will not include only greater than values, we will take 3 also, okay. Similarly, if we have only less than sign, so it means x is less than 3, for example, so it means that only we will have values less than 3, but 3 will not include. And if we are having this sign less than and equal to, and for example we have x less than and equal to 3, so all numbers less than or equal to 3, and in this case 3 will also include, okay. So if we have only greater than sign or only less than sign, so that particular number will not be included, or if we have greater than and equal to, less than and equal to sign, then the particular number will be included also. Now the second most important thing is transformation for inequalities. So remember, we can add or subtract any number, okay, from both sides of inequality, and similarly we will multiply or divide any inequality by a positive number. But the most important thing is, if we multiply or divide any inequality by a negative number, then the sign of inequality will flip. Again, I am repeating this last point. According to this point, if we multiply or divide any inequality by a negative number, then the sign of inequality will get changed. If it is less than, then we will change it into greater than, and if it is greater than, then we will change it into less than, okay. Here I have taken one past paper question to explain you this last point. Here I have taken this question from November 2011, paper 1, question 6. In this question they are saying, solve the inequality 2 bracket 4 minus x less than x minus 10. So if we open this bracket, so 2 times 4 is 8 minus 2x less than x minus 10. Now if I shift this x on the left hand side and 8 on the right hand side, so it will be minus 2x minus x. When we shift x on the left hand side, it will be minus x less than minus 10, and when we shift this 8 on the right hand side, it will be minus 8. So here we added, so minus 3x less than minus 18. Now when we shift this minus 3 on the right hand side, it will get divided by minus 18. So basically here we are dividing this inequality by this negative sign minus 3. So as we have discussed that if we have a point in which we have to change the sign of inequality, then in which condition we will change it? When we multiply or divide any inequality by a negative number. So here when we shift this minus 3 on the right hand side, we will change the sign of inequality. So it will be minus 18 upon minus 3, because we are dividing this inequality by negative 3. Okay, so in this case we will change the sign of the inequality. So see here, I have changed the sign of inequality. So now x is greater than minus 18 upon minus 3. So minus and minus will get cancelled, and 3 times 6 is 18. So the answer is x is greater than 6. So x greater than 6. Now in the next part they are saying find the smallest integer n such that 3n greater than minus 17. Now in this case, when we shift 3 on the right hand side, as it is a positive number, so we will not change the sign of inequality. The sign of inequality will be exactly same, greater than. So n greater than minus 17 upon 3. So if we divide minus 17 upon 3, it will be equal to minus, it will be 5.66. So n is greater than minus 5.66. Now here they are saying find the smallest integer n such that 3n greater than minus 17. So remember, whenever they are saying integer, so integers are not whole numbers. These are integers are not decimal number. These are whole numbers. Okay, so with a positive or negative sign. So all these numbers with positive and negative sign are integers. Okay, so 5.66 is not an integer. Okay, so if we write the smallest integer, so let's see that if we draw a number line of this, so here we have minus 5, minus 4, minus 3, minus 2, and so on, and here we have minus 6. So minus 5.66 will be in between minus 5 and minus 6. So if we mark this circle here, 5.66, so as they are saying n is greater than minus 5.66, so on the right hand side we are having greater values. Okay, so on the right hand side we are having greater values. So if we check that what is the first integer value here, so see, the first integer value is minus 5. Okay, so here answer is minus 5. So the first integer value or the smallest integer value is minus 5. So answer is minus 5. Okay, now this is the most important part of the linear inequalities, like graphical solution of linear inequalities. Here, for example, on a graph we have this line, and the equation of this line is y is equal to x plus 4. Now if we are saying that y is less than x plus 4, okay, so remember that whenever we have a diagonal line, either like this or either like this, okay, these two are diagonal lines. So in these two types of diagonal lines, the below region of this line is lesser region, this is lesser region, and the above region of this line is greater region. Similarly, here we have lesser region and this is greater region. Okay, so if we have equation of this line as y is equal to x plus 4, so the below region of this line will be y is less than x plus 4. Okay, and similarly the above region of this line will be y greater than x plus 4. Okay, now I am having few examples here. So this one is the equation of this line is y is equal to x plus 4. Now here let me tell you one more thing, like whenever we have a dotted line, so we will just write greater than and only less than sign, only greater than and only less than sign. And when we have solid line like this in the second example, here we will write greater than and equal to and less than and equal to sign, because the solid line represent that the boundary is also included, and when we have a dotted line, so it means the values on the boundary will not be included. Okay, so here we have equation of this line as y is equal to x plus 4. So basically here we have a diagonal line and the above region is shaded. So when the above region is shaded, so it means here we have a greater region. Okay, so which inequality sign we will write here? We will write y greater than x plus 4. Okay, not greater than and equal to, because we are having dotted lines. Now if we talk about the second example, here we having equation of this line as y is equal to half of x minus 4. So basically here we have a solid line, and the below region is shaded. So the below region is lesser region. Okay, so when we mark the inequality sign, we will write y less than and equal to half of x minus 4. Because we are having a solid line, so that's why we will write less than and equal to sign. Okay, when we have dotted line, we will write only greater than and only less than sign, and when we have solid lines, then we will write greater than and equal to and less than and equal to sign. Now for example, if we have a straight vertical line passing through x1, x2, x3, x4, x5, or x minus 1, x minus 2. So for example, we are having a line x is equal to 3. This line is x is equal to 3. Now remember one thing, like on the right hand side of this line, the x values are increasing. So on the right hand side, we are having greater region. Okay, and on the left hand side of this line, as the x value is decreasing, so on the left hand side we are having the lesser region. So right hand side is greater region and left hand side is lesser region. If they are saying to mark or shade the region according to the lesser one or greater one, so we know that whenever we have a straight vertical line, right hand side values are greater region because x values are increasing here, and the left hand side is lesser region because x values is decreasing here. Now if you are having, for example, a line here, this line, this one is x is equal to minus 3. So remember that the right hand side is greater region and the left hand side is lesser region. Okay, because the x values are increasing on the left hand side and increasing on the right hand side. Okay, so whenever we have a straight vertical line, right hand side is greater region and left hand side is lesser region. Now for example, if we are having a straight horizontal line like this, if we are having a straight horizontal line like this is line y is equal to 4. Now remember, whenever we have a straight horizontal line, as the y value is increasing above this line, so the above region is greater region and the y value is getting lesser on the below region, so below region of this line is lesser region. Similarly, if we have a line here, for example this line is y is equal to negative 3. Now as the y values are increasing above this line, so above region is greater region and the below region is lesser region. Okay, so whenever we have a straight vertical line, right hand side is greater region, left hand side is lesser region, and similarly if we have a straight horizontal line, then the above region is greater and the below region is lesser. Now here we have more examples. So they are saying graph the linear inequality 2x minus 3y less than and equal to 6. So here when we draw this line, we have got this one. Now as we are having this line 2x minus 3y is equal to 6, and according to this inequality we are having less than and equal. So in these cases they have represented through unshaded region. Okay, so less than and equal to is our white region below this line. Okay, so here this region is less than and equal to, and similarly in the second example we have 2y minus y, 2x minus y greater than 3. So see, as I have told you that whenever we have a diagonal line, okay, so the below region is lesser region and the above region is greater region. So here in this case they have represented this white region as a greater region, so we have this region as a greater region, and you can see that here we have only greater than sign, so that's why we are having dotted line. And in the first example, as we are having less than and equal to sign, so that's why we are having a solid line here. Now here we have more examples, and they have we have represented here also, like graph the inequality, linear inequality y greater than minus 3x. Now in this case we have represented the colored one as the greater region. Okay, or as a required region. So graph the linear inequality y greater than minus 3x. So as we are having this line, okay, so the greater region is above this line, so this colored region is greater region. And as we are having only greater than sign, that's why we are having only dotted line. And on the right hand side example, the graph of linear inequality is y less than 5. So as I have told you that whenever we have a straight horizontal line, the below region is lesser region and the above region is greater region. So see here we have this line y is equal to 5, and as they are saying y is less than 5, so the below colored region of this line is y less than 5, and we have represented this through a dotted line because we are having only less than sign here. Okay, before I end this, let me review all these things once again. Like whenever we have a greater than sign, then for diagonal lines, okay, either we have line like this or line like this. Okay, the above region is greater region and the below region is lesser region. Above region is greater region and the below region is lesser region. When we have a straight vertical line, okay, like x is equal to 0, x is equal to 1, x is equal to 2, or x is equal to minus 1, minus 2, okay, all these are straight vertical line. So on the right hand side, as the x values are increasing, so here on the right hand side we have greater region, okay, and on the left hand side we are having lesser region. Why? Because on the left hand side the x values are decreasing. Now if we have a straight horizontal line like this, okay, so as the y value is increasing above the line, okay, so the above region is greater region, and as the y value is decreasing below the line, so that's why the below the line region is lesser region. When we are having solid lines, we will write greater than and equal to and less than and equal to sign, and when we are having only greater than and only less than sign, then in that case we will show this with a dotted line, as we have in both examples dotted line, because in the question we are having only greater than and only less than sign. Okay, I hope you have understood this.